Okay, so today we are discussing about what is data resiliency. Okay, first, see, I just want to go through some of the topics. Okay, like what is resiliency, what is factor, RF factor, replication factor. Then we can go ahead. Okay. Mm. So data resiliency is the ability system withstand and continue withstand and continue to perform after damages or loss of infrastructure. Redundancy is achieved through the duplication of the services. It enables the continuity of communication when primary communication capability support the damage to the diverse in alternative methods. Okay. So you might have seen, like you might have faced in some of the interview, they might have asked you what is resiliency, data resiliency, what is redundancy. Resiliency is nothing but even after damages, your infrastructure is running. Even one node goes down, even RAM or CPU fails, your data resiliency means your infrastructure is still running. And redundancy is nothing but you configured, like you might have heard in RAID configuration, redundant factor, how much redundancy factor is there available. If you have RAID 1, you have only one redundancy. If you have RAID 5, you have three redundancy. You can have, if one disk fails, you'll have the data on other disk. So three redundancy factors. So like that, here in Nutanix also, data resiliency and data redundancy. So there are, what is the Nutanix redundancy factor? Nutanix redundancy factor RF2 or RF3 is a technique that is determined how many components can be sustained in case of failure, deliver non-interruption operation. So redundancy factor 2 and redundancy factor 3. Let me open a pen so you'll understand what is redundancy factor. Okay, you have three nodes. Okay, you have three nodes. So if one node goes down, you'll have other two as redundant. So this is two factor redundancy. Okay, and if you have more than three nodes, you'll have three redundancy factors. How much? Like node, this is your node one, node two, node three. Okay, here we purchase a new Nutanix box which has four nodes. Okay, so one node to two, one redundancy, two node to three, three redundancy, second redundancy, and three node to four, it is third redundancy. Here, one node to two, one redundancy, and two node to three, two redundancy. So, if you purchase three node cluster, you will have two redundancy. Okay, two. Here, we'll get three. Okay, so basically, this this is the specific question asked here interview. How how many nodes do you have installed and configured in your infrastructure, in your office or in your data center. So you may tell it's 3 node cluster. Okay. Then again they will ask what is the RF factor. So you should answer that question. The redundancy factor is 2. Okay. Here the redundancy factor is 3. Even one node goes down, we will have rest 3 nodes. So 3 redundancy. The redundancy factor 2. Okay. If your one node goes down, this node goes down, we'll have 2 redundant factors, right? So this is about the redundancy factor. Redundancy factor 2, redundancy factor 2. Okay. Minimum 3 node in cluster. Redundancy factor 2 means, as I told you in friend, for 3 node cluster, redundancy factor 2. Okay. You have how many node you have? 3 nodes. And how many redundancy factor? 2. Okay. So CVM with 24 GB of RAM configured. The minimum redundancy should be, you should have CVM. CVM is nothing but the virtual machine attached to your each node. So here we'll have one CVM. CVM basically is used to configure your storage pool, your services, your zookeeper. All these services are managed by this node. Okay. So to configure this CVM, you should have 24 GB of RAM to assign this CVM. Okay. Like that, every node will have CVM. So okay, this is the practical. I will tell you. I will go through later how you can configure the redundancy factor, where you need to go, how you can configure the redundancy factor. It is nothing but HA. HA in our ESXi environment, HA is configured like that. We have the HA. It is called here in Nutanix RF factor, redundancy factor. Okay. So redundancy factor, how you define? So this is the node one. Okay. Inside the node one, you have block. Block one. The below one is block one, block two. Okay. So inside that you have another the like child node. These are called child nodes. Inside that you will have the child node. Node 1, node 2, node 3, node 4. If one node goes down, if CPU or RAM fail on this node, we'll have other 3 nodes. Okay. So this is called the RF factor. So one node goes down, we'll have another 3 nodes. Okay. What is RF factor 3? RF factor 3 minimum node required. How many minimum node required? You require 5 nodes. 5 node cluster or 5 block, 5 rack. CVM should be 32 GB. Like here, we configure CVM. So 3 redundancy factors would be you should have like 5 nodes. Okay, 5 node cluster means you will have 3 redundancy factors. So each node will have CVM. CVM is used to manage your virtual machine, your storage configuration. Okay, so I will tell you what is RF factor. Then we will go to like Prism Central. There we'll manage, create virtual machine. We can manage everything. Just try to understand what is RF factor. So this is very important thing in Nutanix. So how you manage the redundancy factor? What is the minimum requirement of CVM? Tomorrow you capture a clone of CVM and you try to restore that CVM, but you assign the RAM less RAM, so it will not work. Minimum RAM should be 32 GB of RAM you should provide to the CV in that CVM. For guest VM, tolerate simultaneously failure of 2 nodes or 2 disks, different blocks, VM. VM data must be stored on container with replication factor. Okay, so here, if one node goes down, you have three nodes, rest three nodes, you can still your infrastructure will be running. You no need to worry if the RAM failure or if entire this node failure, you have another three nodes in that box, right? So how this redundancy factor will work? Because they store the data in such a manner that particular character will store the next character store on another node. Suppose you write A B C D. Okay, A will mm, A will be right here, B will write here, C will write here. Then again D will write here, C will write here. Again A will write here, A will start from here, B will write here. So you will have redundancy, data redundancy you will have. So this is completely RAID configuration kind of thing. If you are aware about what is RAID configuration, you will understand how we can configure the node and RF factor. Suppose here, if your CVM goes down in particular node 1, suppose in your Nutanix, you have node 1, node 2, node 3, and you get a ticket, you get an alert that CVM failed on particular node. So you don't need to worry because the CVM will be completely managed by other two. So whatever the CVM is doing here, if it goes down, these operations will be diverted to other CVM. So for this node, all the operation will be handled by other node CVM. This node CVM, this node 2 CVM, node 3 CVM, they will manage all the work, all the storage controllers, handling storage controllers, migrating data, migrating virtual machine will be handled by the other CVM. Okay. So you may face that the unavailability of CVM will impact your replica, right? But it is not the case. You have other CVM, they will manage your VM. Other node CVM, they will manage your VM. So you no need to worry. You can create your own CVM in your environment, in your infrastructure. You might have virtual machine. You might have Nutanix, and you might have backup backup server configured, or you have backup configured on Nutanix. You can take a clone and you can restore that CVM. No need to worry about that. Okay. So the same like redundancy factors, node 1, node 2, node 3, and node 5. Okay, you have, if your CVM goes down, this VM will be migrated to, if your node goes down or CVM goes down, this VM will be managed by other CVM. Here in our VMware, if suppose ESXi goes down, suppose one ESXi goes down, what will happen? The virtual machine will restarted on other nodes. But here, your virtual machine still is managed by other node CVM. Directly connected, it will directly migrate it. Benefit here is the virtual machine will not be restarted. Okay. So mechanism is like writing mechanism. So new write service by the remote CVM. So this CVM will manage your all writing operation, whatever suppose data is getting increasing, migration, storage pool, inside the storage pool, how the CVM will work. All these things are managed by other CVM. Okay. Suppose in case your CVM and node both are down, still your VM will get migrated to other nodes. one VM will migrate to node 2, one VM will migrate node 3, one VM will migrate node 4, like that. And all these are directly connected to the CVM. All the connection of CVM are connected internally, so you no need to worry. So all the connection of CVM, this CVM is connected to this CVM, this CVM is connected to this and this to this. So all are connected internally. If one node goes down or one CVM goes down, this CVM will manage the VM running on node 1. They will directly migrate those VM to other nodes. Okay. Hello? Uh, I'm not getting your response, man. Anup, Imran, Sandeep, can you just give me response? Sandeep.
Yeah, hi. I've been listening to this. I'm new for this thing. I'm looking after this. I have to go for first video. Later, I will
Okay.
explain. Later, I
Okay.
can ask you.
Okay. So, see, suppose you have redundancy, three redundancy factors you have configured. Suppose your node 1 get failed and node 4 get failed. What will happen? So you no need to worry, because you have like basic information that if you have RF factor 3, the data loss will be like 2 nodes or 3 nodes. If failed, your infrastructure will still running, right? So you don't need to about that. Tomorrow, if you receive the alert that two nodes are failed on your infrastructure, your VM will still running, because this VM will be managed by your CVM, and the CVM will migrate from node 1 to node 2, from node 4 to node 5, or node 4 to node 3. This VM will be managed by your CVM. So all these replicas, remote replicas, are distributed through the cluster. So that is the main important three Nutanix cluster, how the VM are managed. This is the main benefit of managing your Nutanix infrastructure. You might not know, like you're monitoring, you're creating virtual machine on Nutanix, you're configuring each and everything you're monitoring, but suddenly two nodes got failed, and your manager is shouting at you, two nodes got failed, why are you not doing anything, you're sitting like nothing has happened. So you can simply tell your manager that we have three RF factors. That means your VM will not lose. They are still running, but they are not running on node 1 or node 2. They are running on node 2, node 3, node 5. They are migrated from one node 1 to node 2. So you should tell to your manager, my infrastructure is fine. Even if my two node goes down, my infrastructure is still running, VMs are still running, storage, each and everything are still running. And backend, you need to raise a ticket with Nutanix and you need to fix it. Okay. Well, that troubleshooting step, I will provide you how you can configure, how you can um, download the NCC log bundle. In NCC log bundle, each and every information stored in that. Even if you want to like analyze that NCC log, you can do that. Like why it is happening. But before doing that, you first thing you should go to like ID rack or ILO tool, go to your system information, check why sometimes like BIOS is not rebooted, firmware is not upgraded. That is the reason node goes down. Sometimes network issues, sometimes OS issues, like CVM is not configured inside CVM. There are some root partition. There are some EDC partition, configuration, VM snapshot partition. Those are full, and those can be cause of failure of your node. So you need to go inside. You take a putty, put your node detail, like whatever the IP of your node, ID and password. Like this is nothing but the Linux server. If you go to a Linux server, uh, you'll face like partition, how this partition SDA1, SDA2, SDA3 partition has created, root partition, user partition, like that. Here in CVM, the CVM is nothing but your this Linux machine. This Linux machine is managing your virtual machine. Okay. So troubleshooting way is putty. You need to connect the putty to your CVM and you can run your operation. Whatever the thing you want to troubleshoot, you can troubleshoot from here. If the CVM is not able to like perform any operation, still your node is like network is fine, you know hardware issue, OS seems to be okay, but these VMs
Mm.
are migrated. So from this CVM, you can connect to this node, okay, and you can perform your operation like troubleshooting operation. There are some troubleshooting steps, troubleshooting commands I will provide you later. So VM will migrate from this here to there. This is the only thing. Data resiliency level, node fault tolerance. If you want to configure the FT, you can configure the FT. This will give you the more benefits than your ESXi VMware. Okay. Mm, Hardware part we have covered. I think no, we have not covered. So this I need to give you first. So we'll go through in a fast manner so you'll understand. So you are aware about what is DAS, what is NAS. DAS is a direct attach, which is directly attached to your server. There is DAS. And NAS is same like network attached. The server are connected to the network and network are connected to the storage. And the storage is called as network attached storage. And SAN is nothing but your storage area network. This is usually used in VMware area. SAN storage, right? You create multiple data stores. You assign that data store to your VMware, your ESXi server, right? Data store is getting full. What you will do? So what is your action plan? So you need to expand your LUN. So you create a LUN and you assign those LUNs to ESXi server. Okay. So SDS object storage, computer data storage, this is like cloud storage. You're creating cloud storage. This is SDS. SDS is nothing but your software defined storage. Software defined storage, like here in CVM, we have created the software defined storage. Okay, let me go to this.
Nothing.
Here,
Nothing. Sorry.
okay, fine. So how this in Nutanix, how the data store or storage is configured. So you have CVM. Okay, let me give you the brief description. CVM. Each node will have the CVM. So what is the main purpose of CVM is managing your storage pool, your Nutanix operation, the zookeeper, and each and everything are managed by your CVM. And AHV is installed on your um, AHV is nothing but your hypervisor. Okay, so you create. So what this CVM or Nutanix will do, it will first create the cluster. After creating cluster, it will create the storage pool. The storage pool will look like this. Okay. and the storage pool are managed by your CVM. Okay. This CVM, what they will do? They will create a storage controller. Each each node will have the storage controller plugin. Okay. This storage controller plugin are connected to your storage. This storage controller plugin, storage controller plugin here, and here also storage controller plugin. So what they will do? They take the storage from each node. Okay. Suppose you have 3 TB here, 3 TB here. Okay. Yeah, 3 TB, 3 TB. Okay. Each node, suppose each node you have 3 TB. What will be the volume? Like 3 into 5. So this node will assign as like 15 TB your volume. Okay. And this you create a small volume on top of that, and this small volume to create you this small amount of nodes will be like small volume will be get created. Okay, volume 1, volume 2, and after that volume you create a vdisk. Okay, that disk, particular small disk you will create. So volume, so the CVM storage, this is the storage pool. What is the capacity of the storage pool? It is 15 TB, and you create a 1 TB of volume. Here you will have like 1 TB, 1 TB. Okay, you have 1 TB of volume, and like that you have created too many volume, 1 TB, 1 TB, 1 TB, and from that 1 TB you created, you assign like in your infrastructure. So you created too many virtual machines, right? So for creating virtual machines, you should give the vdisk. In VMware, we assign a VMDK file, right? Here we are creating virtual disk. Okay. So let me give you another example here. In this node, you'll have too many switches, network switches. So same thing, like one switch, network switch goes down, you'll have other three switches, network switches. If one CPU goes down, you will have other three CPU. If one RAM goes down, you'll have other three RAM to manage your infrastructure. So here in Nutanix, you get more redundancy. Okay, so network pool will get created. On network pool, you'll create a small subnet. Okay, on subnetting, like you create a subnet. On subnet, you one subnet you have assigned for IT, for finance, for like your sales department. You have assigned three different networks. For these three networks, you need to connect your plugin to your virtual machine. So this thing you should understand while creating your virtual machine. If you are creating virtual machine, you should know like which volume you need to choose. which subnet you need to choose, which network you need to choose, and then you need to assign the VDIS. Okay, you got my point. Just give me response so that I can go ahead. Okay, hello. Okay, so these are the some NVMe. This is the flash drive, SSD, HDD. So these are the mainly used storage in your data centers, right? So Nutanix, why when you're purchasing Nutanix, you need to configure in a such a way that how many you want to purchase the Nutanix hybrid storage or fully SSD or hybrid storage with SSD flash drive or SSD HDD. So older data will store on HDD. The running production data will be running on your Oracle server. Okay. So NAS network devices, some of the this is your uh, data center. Mm, In data center, you this is the rack mount. Here you put the Nutanix server protocol. You may be using some protocol like ISCSI protocol, FC protocol, or FCOE protocol. FC is fiber channel protocol. ISCSI is mainly used or defined by like Microsoft protocol, and it is used to like connecting the your hard disk. Okay, and FCOE is like fiber channel over Ethernet connection. So you have fiber channel, but the connector is Ethernet connection. Okay, block storage and Nutanix block volume. So these are some storage term you should understand. So what is iSCSI? Mainly in Nutanix, we are using the iSCSI storage to configure your data, you configure your server, to configure all the storage controllers depend on iSCSI. And FC are like your fiber channel connected to your from one node to another node to third node, fourth node, all are interconnected with your fiber channel. This is a typical like diagram for DAS, NAS, and SAN. DAS is nothing but your direct attached storage. NAS is the network attached storage where the networks are connected. If any network goes down, your storage will be filled. The SAN, this is the shared storage where RAID are configured on top of that. If there will be one redundancy, like we have covered redundancy factor, in SAN, same like that. One storage gets filled, your other two nodes, this will run your infrastructure. Mm, this is again your elastic block storage. This is your cloud term, Google storage. In Azure storage, you are using like block storage, right? In AWS, you're using S3 bucket, right? In Google, you are using persistent disk. In Nutanix, you can connect your Nutanix object to your AWS, your blob storage, your Azure storage. Okay, software defined storage. Software defined storage is defined by your hypervisor. The hypervisor in Nutanix, what is the hypervisor? AHV is a hypervisor. The main operating system running on your Nutanix, it is called as AOS, Acropolis Operating System. In VMware, the storage is defined by the vSAN. vSAN is a software, and this software is managed your virtual SAN storage. Like in Cisco Hyperflex is another SAN storage. Okay, now this is your node 1, node 2 data center regulation, how the data center are managed. So this is node 1, node 2, node 3, all nodes are connected. to your virtual machine. And virtual machine, this is some of the IOPS. Okay, 33K IOPS, 33K IOPS, 33K IOPS. IOPS is nothing but your input output per second operation on your storage. Okay, you have storage separately, and this to connect to your like the vCenter server, it requires some network connection. And this network connection, if this network connection giving the slow speed, your IOPS will be affected. You may face slowness on your virtual machine. You need to continue monitor your IOPS, right? But here in Nutanix, our storage are not different, right? Our storage are clubbed together. So this is the same thing. Okay. High IOPS means high throughput, right? Low IOPS means low throughput. If you have high IOPS, means you have like performance, good performance. If you have high IOPS, low IOPS, like you have degraded performance. Okay, this is your okay. Here missed one thing. Older thing, what we are using, this and that, all these things are mentioned here. Okay, hyperconverged platform. So this is your converged infrastructure. In converged infrastructure, you have server, you have other servers, the application running on top of your virtual machine. On virtual machine are connected to your ESXi server, node 1, node 2, node 3, and storage are located in different locations. They might be in different box, different rack storage server, and these storage servers are connected using the fiber channel, fiber cable, or Ethernet cable, FCOU. So these are not connected to your ESXi directly. They need to connect first to your switches, and from switches to your server. So there will be dual switch, stack switch, and one switch goes down, you have redundancy. This is the infrastructure of your uh, mm, traditional data center environment where your storage are put uh, in a one storage server box, whether it is like NetApp storage or IBM storage, SP3 per storage. But in hyperconverged, you have all together. You no need to go to network, then switch, then from switch to another network, from another network to your storage. So it will give you the like it will impact on your storage performance, right? Here in traditional environment, you may face like the data speed is very late, the application performance is very low. So in Nutanix, the storage, your CPU, all together inside that box. So you no need to worry about your performance on network, on storage, on application. All are together, clubbed together, and they create a cluster on top of that, and cluster will be managed the storage, right? And easily you can scale out. Today you have three nodes. You can directly attach another node like node 4, node 5 easily. If you want to scale out, you want to grow, or you want to expand your storage. So I will tell you the steps how you can expand the storage. Okay, hyperconverged, as you can see, the hyperconverged system does the following: virtualize and move the controllers to to the host, provide the core service and logic through the software. So all these are software defined hyperconverged. So CVM, we see in the CVM, so CVM are connected, are hosted to each node, and this each CVM will manage your storage, your network, your operation, your zookeeper, Stargate, Medusa. All these operations are managed by this CVM, right? and the CVM are connected internally connected to each other. So you don't need to worry about your network performance. You don't need to worry about your storage performance, and that is the main reason. Because of you get the higher performance, all your like storage and network are clubbed together. That is the reason you get the high performance. And because of that, the banking or your capital market or share market, most of the production environment, mainly they are using Nutanix instead of going to this vCenter server or your cloud. They are preferring to get this Nutanix in their production environment. This is the Nutanix, okay, basic architecture of Nutanix, how this Nutanix is supposed to be. Like it will have like two power plug connection, two fans and blocks. Server 1, server 2, server 4, server 3, server 4. Okay, you have five servers included in one Nutanix box. It will have 10 gig Ethernet network connection, USB port available, VGA port available. So if one server goes down, you have other servers, other blocks, right? This is the node A. Node A will have virtual machine, some of the virtual machine and data store basic. This is the basic architecture. Okay, in basic architecture, this data store is nothing but your storage pool. Okay, later we'll see this in real practical how you can connect and create the own storage pool, how you can create volume on top of that storage pool, on top of storage pool volume, how you can create the VDISK and that assign that VDISK to virtual machine. Okay, same way you can create your network, different subnet for different departments, and that subnet you can assign that subnet. You can virtual network inside that subnet. You can create VLAN. Okay, different VLAN, and those VLAN you can choose inside your mm, uh, virtual machine. So it will provide you more security. Network wise, you will provide more security, more faster, and storage wise, you get more throughput, more IOPS. That is the reason we are using Nutanix. Okay, KVM, you have other hypervisor like Hyper-V, KVM, vSphere, um, Zen server. These all are like software, virtualized software server. Like hypervisor you're running V and Hyper-V. Previously Hyper-V it was the hypervisor 2, but now it become hypervisor 1. You can install and configure a server on directly on your bare metal machine. First you need to in Windows operating system. On top of that Hyper-V manager you can install. Same like vCenter server, you need to install ESXi server on nodes, and then on top of ESXi server, you can connect to manage all this ESXi server. We need to use vCenter or vSphere client, right? Then server is different. So this is the main component of your like operation. Suppose Stargate, Medusa, what they are doing. So they are sending the data. They are migrating virtual machines. They are talking to each other. They are sending the heartbeat, storage heartbeat, network heartbeat. They are like enabling the port connection. So you might have certain ports. They are connecting to port and give them information, right? So those things, what all those things. So this is the main important thing of Nutanix. Definitely in each interview question, they will ask you what is the cluster component. So you should tell them what is about the Stargate, what the Stargate will do. Stargate will do the data IO manager for the cluster. Whatever the input, output are coming, so this target will provide all these things to your Cassandra and Zookeeper and Prism Central, Prism element. Okay, and this Prism element you are managing from your browser, right? Medusa, access interface information for Cassandra. So Medusa is a bus between Cassandra and Curator. What Curator will do? Curator handle the map, reduce the cluster management, and clean up the data. The Curator is like act as a cleaner. It, it cleans a mess, whatever the temporary file gets created, or unnecessary data, or orphan image of your snapshot. These snapshots will get deleted by your Curator. Okay, Zookeeper manages a cluster configuration. Whatever the cluster you configure, all these clusters are managed by your Zookeeper. And what Zeus will do, Zeus will access interface for the Zookeeper. This is the interface. Or if you want to talk to Zookeeper, you should have Zeus. Zeus is nothing but your interface. Interface 1, interface 2, interface 3. These are the Zeus. And through Zeus, you can connect to Cassandra. Cassandra to ShareGate. ShareGate is responsible for I operation. Zookeeper is configuration of your cluster. Cassandra is like distribute your metadata store. Whatever data about data, if you want to know which file is what from location, if you have tail file from orphan file, and this file you should know. So Cassandra will tell the cluster that this snapshot is belongs to node 2. On the node 2, one virtual machine which is belongs to finance service, finance department, this is belongs to that location. So all this information are provided by Cassandra. This cluster configuration, Cassandra will give you the metadata store, and Zeus, Zeus is nothing but your interface of Zeus keeper. And curator is for clean up the job. Whatever the mess, whatever the like temporary file, cleanup, data cleanup activity, unnecessary the storage pool is increasing. So curator will delete some unnecessary data from your data center, from your cluster. Okay, and Prism, you know, like Prism is management tool to manage your all infrastructure, right? Prism is another service running inside the cluster, which is used to manage the interfaces for Nutanix UI and CLI APIs. Okay, as I told you, one CVM. This CVM is managing all your infrastructure. This CVM is managing your all node infrastructure. This CVM is managing your all node infrastructure. But to manage to connect this CVM, it it has some prism interface. If you want to connect to your CVM, you should you should have like prism interface. If the prism interface is not working, you will not be able to log in on your CVM. Like prism is very important role. Prism service. Prism is a component of your cluster. So Prism Central, Prism Element, these are the management console, but Prism interface is used to provide your connection to your infrastructure, actual infrastructure. What is the hypervisor you're running? What is the storage you're running? Okay, what are the network you're running? All this connection will be provided by your Prism. Prism is nothing but is used to manage interface for your Nutanix UI. The NCLI, like in vCenter, if one of the ESXi node goes down, how you will troubleshoot that ESXi server? So you need to use some EXCLI command, ESXCLI command line tool, or PuTTY tool. So to connect those things, you should have like one CLI. Okay, For Nutanix, we have a separate CLI called NCLI. Okay, so we need to connect the putty and we need to connect, give some information, then connect to CVM. So once you connect to CVM, you can troubleshoot all the environment, like how many services are running, the services, all these zoos are running, Prism are running, curator stop because of some network interface, or zookeeper is stopped because of Prism interface is not working. Prism interface is not working because the network Ethernet has not capacity to enable that particular interface. So these kind of troubleshooting steps I will provide you. And once you are okay, once you understand each and everything in detail, in basic, this is the basic information. If your basic is good, then you can do troubleshooting no matter what level you are working, level 2, level 3, level 4, you'll be able to troubleshoot that failure. Ignored failure, mm, so error occur, you need to install KB like that. This is the like traditional infrastructure. This is your hyperconverged infrastructure. Same thing as we discussed. So Nutanix, Nutanix could be IBM Nutanix, Nutanix could be Dell Nutanix, Nutanix could be Lenovo Nutanix. Okay, these are the hardware vendors. These vendors are providing they have dealt, they have done a deal with Nutanix that we will install and configure your hypervisor storage in our storage box and we will sell it. So they give per host licensing will be there. So basic the difference why like today the main reason why the VMware user are moving to Nutanix, the basic difference is you do not have to pay license per core. So Nutanix will not charge for that. Whereas today in my company, see, I'm working in one of the like largest company in USA. So they want to